All right, let's talk about hypothesis testing for the mean of a population. So we're talking about one single population when the population standard deviation is known. In this case, we have a data set. So the problem reads, Megan is a psychology major who is testing a maze for a group of mice to navigate. In order for it to be productive for a class project, she would like the average time for a mouse to complete the maze to be 90 seconds. She randomly selects 28 mice and has each mouse complete the maze. Megan records the time in seconds that each mouse needed to complete the maze. The results are provided in the table. Based on research and previous results, Megan assumes that the population is normally distributed and the population standard deviation is 5.8 seconds. We're going to use RGuroo to test whether the mean amount of time a mouse completes the maze, it's 90 seconds. And then we're going to draw conclusions in the context of the problem where alpha is 0.10. So we have multiple choice in here. We need to choose whether we fail to reject the null hypothesis or we have the evidence to reject the null hypothesis. But before that, we need to go ahead and conduct the test of hypothesis using RGuroo. Because we have a data set, we're going to download the CSV file to our computer. We go to RGuroo and we are going to import that data set into our software. All right. Again, I always change the name. So that we know which one is it when I look in my huge list. All right, so to complete the test of hypothesis, we go to analytics, we go to analysis. We are talking about a mean inference. This is a hypothesis testing for the mean of a population. It's just one. So we only have one column. We only have one population. And this is the same place where we do confidence intervals because they are absolutely 100% related. So let's choose our data set. So it's down here, time to complete the maze. We're going to choose our variable. And then here I know that I'm working with the data set that I need because that's the name of the variable time. All right, so RGuroo calculated the sample mean, the sample standard deviation, and the sample size. So here is my 28 for the 28 mice that Megan selected. We know the population standard deviation is given to us in here is 5.80. So we're going to write this in here. Right, we need that because RGuroo uses the population standard deviation to find the test statistic. All right, so then I am going to calculate the confidence interval. So this is an alpha of 10%, meaning that my confidence interval is 90. Remember that the confidence level plus the alpha makes 1 or 100. So if alpha is 0.10, then I have a 0.90 left, and that is my confidence level. When we know the standard deviation of the population, our method is a z-statistic. Let's talk about the test of hypothesis. So the significance level is your alpha. So we're going to change the significance level to 0.10 because that is where what the problem is asking us to do. We need to figure out what is the alternative hypothesis. I'm going to talk about that in a moment. For our method, we're going to do the same thing. So we're going to use the z-statistic for the test of hypothesis and the z-statistic for the confidence interval. So we don't change our method. So let's see. She, for her project, she wants the mouse to complete the maze in 90 seconds. This problem is not telling me any direction. And so because it's not telling me direction, I'm going to do a two-tailed test of hypothesis, meaning that I'm going to choose the different than, which is that exclamation point and the equal sign of 90. So then what I'm saying in here is that she wants to test the null hypothesis of the mean time being 90 versus a mean time that the mouse needs to complete the maze is just different than 90. Less than, greater than, she's not offering us any direction, so we just go with the different than. Once we have all of that, we click the I. This is your output. So this is a summary. So that's the name of the variable. The sample size is 28. The mean for the sample is 91.13. The sample standard deviation is 5.85. The population standard deviation is 5.8, which is the given one. We have the confidence interval in here. We already know how to read this. So we did a 90% confidence interval. The lower for the confidence interval is 89.33. The upper is 92.93. And here comes the test of hypothesis. So when we look at this, we need to look at the p-value. And we compare, we can do either. Remember that we have a p-value approach or a critical value approach. So then the p-value approach asks us to compare the p-value with our alpha. If the p-value is greater than the alpha, which is 0.10, so you see how 0.30, it's bigger than 0.10. So because my p-value, it's bigger than my significance level, I fail to reject the null hypothesis. So we don't have evidence to say that the mean time needed for the mouse needs to complete the maze, it's different than 90, which is our alternative hypothesis. So then we go here. So it's definitely not this because we don't have the evidence to reject the null hypothesis. It's either the first one or the second one. So the first one says we fail to reject the null hypothesis. Yes, that's our case. P-value is greater than the alpha. So 0.30 is bigger than 0.10. So it says there is sufficient evidence at the 0.10 level of significance to conclude that the mean amount of time a mouse complete the maze is greater than 90%. We don't have evidence to conclude this. On the contrary, we are failing to reject the null hypothesis because we have insufficient evidence, like we do not have the evidence to reject the null hypothesis and say that the mean amount of time a mouse needs to complete the maze, it's different than 90 seconds. So our response is going to be this one. When we fail to reject, it's because we have insufficient evidence. When we reject the null hypothesis, it's because we do have sufficient evidence to go against the null hypothesis and say that and go with our alternative hypothesis. So this is the answer for this one. So we submit. There we go. Let's try another one. All right. So here we need to start by choosing our null hypothesis and our alternative hypothesis. Hayden is an editor for a local newspaper. The newspaper's editor-in-chief asked Hayden to determine whether the average distance a reader leaves from the newspaper's headquarters is greater than 25 miles. He sent a survey to a random selection of the newspaper's readers and received 30 responses. Using the results from the current study and several previous surveys, Hayden decided to assume that the population standard deviation for the distance the readers leave from the newspaper headquarters is 12.3 miles. Hayden conducts a one mean hypothesis at the 5% significance level to test if the average distance a reader leaves from the newspaper headquarters is greater than 25 miles. All right, so what is the hypothesis? All right, so then we have 25 miles. So 25 miles is going to be our null hypothesis. So this 10.3, we don't have that 10.3 never, like in this story. So the null hypothesis is like the given, it's our starting point, it's the given one. So we are going to assume that the null hypothesis is that the mean of the distance is 25 miles. Now the alternative is going to be taken from here. It's the test that he is doing. So he's conducting the hypothesis test to test if the average distance is greater than 25. So then we're going to click in here and we have a null hypothesis of, well, the mean distance is 25 miles versus his claim, which is that the mean in distance is greater than 25. This is a right tail test, meaning that we are only looking at the tail of the right because of the direction given. Once we move from here, now we have the data. So we choose our alternative hypothesis, like null and alternative hypothesis in part A. It's the same problem. So part B is asking us to conduct the test of hypothesis and find the test statistic and find the p-value. So we're going to do exactly the same thing. I'm going to download the CSV. I'll go to RGuroo and I need to import this. So I'm going to choose the file here. And then again, I'm going to change this. I'm going to call the distance. So there it is. So then now I go to analytics, I go to analysis, I go to mean inference one population. Once we are there, I'm going to select my data set. Again, select your variable. So the sample mean is 26.4. Standard deviation for the sample is 12.19. I have a sample size of 30. And the population standard deviation is given here. The population standard deviation for distance is 12.3. So that 12.3 goes here. I'm going to calculate the confidence interval again, just to have it in there. So this is okay. So when we don't have an significance level in here, so I am going to use. It doesn't really matter because what we need is the test statistic and the p-value. We're not comparing with anything. So I'm going to keep it 5%, which is the usual. In here, we already know what the alternative hypothesis is. It's greater than 25. That was per A. So this is your alternative hypothesis, that the mean is greater than 25. So I'm just going to add that in there. So every time we know the population standard deviation, our method is going to be a Z statistic. And we click in the eye. All right, so once we click in the eye, again, here is your lower and upper for the confidence interval. Now, your test statistic is this observed Z stat. So this 0.623424 is our test statistic. I'm going to copy and paste it here. And it says to use 3 decimal places. So I need only 6 to 3 and read to round. And then the p-value, but then it's this number in here. So again, 3 decimal places. So I'm going to copy, I'm going to paste. So the p-value is 0.266. I'm going to change that to 267 because of the 5 afterwards. All right. So again, from the output, this table in here is your confidence interval. The next table is your test of hypothesis. Your test statistic is the observed Z stat. And your p-value is going to be the last one in that table. All right. And so you write the names, the numbers in here, and then you are done. I think I'm going to get a new one. So let's see. All right. So then now we have that. We did it. So now, which of the following is true? So we have our test statistic 0.62, our p-value 0.268, and it says, for which of the following are appropriate conclusion for this hypothesis test? And select all that apply. All right, so assuming we are doing a hypothesis test at a 95% or with a, I'm going to say, oh yeah, it says in here, a 5% significance level. I missed that. Yeah, and it didn't mention it again. So it's at the beginning. Kaden conducts a one mean hypothesis at the 5% significance level. So we did it right, because we did a 95% confidence interval and a 5% significance level for the test of hypothesis. So let's go here. So then what do? We need to compare the p-value with our alpha. So again, alpha, it's 0.05, which is the 5%. And we got a 0.2. So 0.2 is way bigger than the 0.05. So then we fail to reject the null hypothesis again. And remember, if p-value is greater than alpha, we fail to reject. If the p-value is smaller than alpha, then we have the evidence to reject the null hypothesis. So then which of these two? At the 5% significance level, the data provides sufficient evidence? No, it is not. That's why we fail to reject the null hypothesis. So at the 5% significance level, the data is not providing me sufficient evidence to conclude that the average distance a reader leaves from the newspaper headquarters is greater than 25 miles. All right, so you need to choose two. You need to choose whether you reject or you fail to reject, and the interpretation of the hypothesis test. All right. So again, I hope this is helpful for you to finish that homework or to complete your homework for this section.